Focus question for today is what rule? Regarding tangents. Can I use to solve triangle problems? What rule regarding tangents can I use to solve triangle problems? A tangent is a line that intersects a tangent is a line that intersects a circle at exactly one point. A tangent is a line that intersects a circle in exactly or at exactly one point. So if you draw a circle on your paper, and then if you draw a line that intersects that circle in exactly one point, it doesn't intersect it yet, does it? Look up for a second. It doesn't intersect it yet, does it? And now it intersects it at 2 points, doesn't it? So right there is where it intersects it at exactly one point. Okay? So this is the tangent. That line, that's the tangent. This point is called the point of tangency. The line's the tangent. The point where it intersects the circle is called a point of tangency. If you add the center of the circle and draw a segment from the center of the circle to the point of tangency, that segment that you just drew, that's called a, what's that called? Good, that's the radius. If a line is tangent to a circle, then it intersects the radius at 90 degrees. 90 degrees. All right, so you can add to your notes that if a line intersects the radius, now don't say that, gonna go back a little bit. A line. A line is tangent to a circle. If it intersects the radius. At 90 degrees. A line is tangent to a circle if it intersects the radius at 90 degrees. All right, so again, a tangent intersects a circle in exactly one place. The place where it intersects with the circle is called the point of tangency. If a line is tangent to a circle, then it intersects the radius at 90 degrees. Okay? So, some of the questions that you're going to be asked today. You will be given a circle, and you'll be given a picture that looks like this. And you'll be asked, the question that you'll be asked is AC tangent to circle B. Okay? Is AC tangent to circle B? And you'll be given some, let's see, maybe a 10 and a 5 and a 15. You'll be given the lengths of the sides of this triangle, and you'll be asked, is AC tangent to circle B? Well, if AC is tangent to circle B, then what will this angle measure be? That'll be 90 degrees, won't it? And if that angle measure is 90 degrees, then this will be a right triangle. And if triangle ABC is a right triangle, then won't A squared plus B squared equal C squared? The Pythagorean theorem will be true. So you can test these sides to find out if this is a 90-degree angle or not. Okay, does 5 squared plus 10 squared equal 15 squared? That's the question you have to ask yourself. If it does, then that's a tangent. If it doesn't, then AC is not a tangent. So 25 plus 100, does 25 plus 100 equal 225? 25 plus 100 is 125. It does not equal 225. Okay? So AC, in this case, is not tangent. Okay? It's not tangent to circle B. It doesn't form a 90-degree angle right here. Everybody see that? All right, question. Is YZ tangent to circle X? All right, is YZ tangent to circle X? what you have to ask yourself is, does 6 squared plus 8 squared equal 10 squared?
Yeah.
Alright, yeah, 36 plus 64, it does equal 100, doesn't it? Okay, so that means that this is a right angle. And if that's a right angle, then the radius and the tangent intersect at 90 degrees. So yes. So that's the rule regarding tangents to solve triangle problems. A tangent's perpendicular to a radius. If a tangent and a radius intersect at 90 degrees, or if a line and a radius intersect at 90 degrees, then it's a tangent. Okay? Alright, second item in this section is on page 734. If two segments from the same exterior point are tangent to a circle, then the segments are congruent. If two segments from the same exterior point are tangent to a circle, then the segments are congruent. So a diagram would look like, you've got a circle, you got a segment tangent to the circle, and another segment tangent to the circle, okay? Both segments are intersecting the circle in exactly one place. So you've got a point of tangency at the top and another point at the bottom. Both segments come from the same exterior point. The rule says if two segments from the same exterior point are tangent to a circle, in this case they are, then the segments are congruent. So in this case, AB is congruent to CB. They are both tangents. So if you're told that one of these segments is x plus 15 and the other one is 2x minus 5, and the question is to solve for x and find the length of AB. Solve for x and find the length of AB. Well, if AB is congruent to CB, then doesn't x plus 15 equal 2x minus 5? Alright, the segments are congruent, so they're equal to each other. So if you subtract x from each side, then 15 is going to equal x minus 5. If you add 5 to each side, then 20 is equal to x. So your x is equal to 20, so solve for x and find the length of AB. Well, x equals 20. And if AB is going to equal 20 plus 15, which is 35. Understood? Any questions? Two rules today. If a line is tangent to a circle, then it intersects the radius at 90 degrees. The other rule, if two segments coming from the same outside point are tangent to a circle, then the segments are congruent to each other. Your assignment for today starts on page 735. Two and three. 4 through 8. Thirteen through 18. Check headline for homework. And answer your focus question.